Hey guys, welcome back. So, we're working today on some electrical stuff. You can see some schematics and stuff in the background, and there's a list of things, and that's a cooling system. But anyway, we're kind of planning stuff out, and we're going to do some electrical stuff. So, the car, one of the problems you run into when you're tuning is you have to have your injector dead times, and it's basically based on battery voltage. It also changes with fuel pressure, but on my car, I run the regulator has 1-to-1 reference, so it has the same amount of pressure across the injector all the time. But you still have the temperature change of the injector, that affects it some. But the main thing is voltage. When you change the voltage up and down, it changes the injector characteristics quite a bit. Now, there's another thing, the ignition coils. So the ignition coils, you change the dwell on those, more dwell gives you more spark. And that's fine, but you only get so much spark. And you run too much dwell, you start to run into problems with overheating the coils and saturating them. And then also, you can only get so much power out of a coil, and that depends on the voltage you give it. And my car usually runs around 15 volts, but sometimes the alternator doesn't keep up, especially if like a bunch of fans are running or something. So where does this lead us? Well, check this guy out. So this is it's called a boost converter. I bought this off Amazon for $40 or something, around $40. Now this isn't really it works. It's not super great, but let me tell you what this does. So these blue wires are hooked up to this power supply. This is like a 12, well, you can adjust the voltage. You can see the adjustment. This goes up to like 15 volts, and it'll actually kick out 50 amps. So anyway, you put voltage in here, and then on the output, you can have almost whatever you want. This won't drop voltage, but it'll raise the voltage. So I think this one will go up to like 80 volts or something. It's actually quite a bit. We're not going to use it that way. So what we're going to do is we're going to hook this to the battery, and then we're going to have an output of 17 volts. Now, why 17? Well, here's the reason. My ignition coils, I run the IGN 1A coils, and these things are rated up to 17 volts. I've heard people run them harder, but they're rated to 17. And 17 volts gives you more power. So, let's see, I'm going to put this in the video, but, so let's see, here's power, right? Power is V squared over R. So, I can't change the primary resistance of the coils. That's fixed. It's whatever it is. I don't know what it is, but it's something. But I can change the voltage going in, and you can see the power is a ratio, so more volts gives you more power, but it's to the square. So, let's whip out a calculator. I haven't really done this math, but I know the equation. So the best case is that we have 15 volts on the battery. So that gives us a number of 225. But what happens if we make that 17 volts? That's only a 2 volt difference. Doesn't seem like a lot, but that bumps us up to 289. So let's do the ratio of that number divided by 225. That's a 28% increase in spark, just going from 15 to 17. So 2 volts, boom, 28% more spark output. But that's not all it does. And here's the other thing. My car doesn't always hold 15 volts when I run max load. Sometimes this drops down to like 13 and a half. I've seen that because the alternator just can't really keep up. So that gives us a number of 182. So let's do 289 divided by 182. That's a 58%, almost 59%. It's a lot more coil output. But it does more than that too. So by having your coils given on really high voltage, you can drop your dwell. So then your like duty cycle on the coil drops, which actually the coils will live longer. They'd rather run high voltage for short times than low voltage for long times. So anyway, that's another improvement. So basically this box is going to do those two things. More coil power, because we're running at higher voltage, and our injectors now run at a constant voltage. So this makes tuning easier because our injectors just kind of do the same thing all the time. So that all sounds great and sounds fine, and it almost seems like why not do it if it's only $40? Well, it ain't as simple as just buying one of these. So let me show you what we're up against. This is a rough diagram of what we're going to do to make this work. Let's see. So these represent the boost converters. We got 3 of them in parallel working together. The way these are rated, you can put 30 amps in and then whatever you can get on the output. So like if you put in 12 volts and 30 amps, then you do volts times amps, that'd be 360 watts. You can get roughly 360 watts out, but if it's at a higher voltage, you get a lower current. Now, my coils can pull 40, 50 amps, maybe even more. So anyway, I just kind of figured that putting 3 of these, I think 2 would actually work, but I put 3 for, that way we're not working them quite so hard, and it could even tolerate one failing and the system would still work. And then coming out of the boost converters, you see these resistors. So you see a resistor and then another resistor. These are, actually I have it right here. I don't know if that's actually the number I picked. I think it's that number, 0.01 ohms. We ended up doing a pair of them, so it ends up being 0.02. But this is for load balancing. So basically, anytime you have a resistor, you get a voltage drop. Well, you would think if you set all these at the same voltage, like say 17 volts, 17, and 17, then they would share the load. But what happens is this one might be 17.01, 16.98, and say 17. Well, the one that's at the highest voltage ends up doing all the work, and these ones at the lowest voltage basically does nothing. So by putting the resistors, you get a voltage drop across all of them, and they end up sharing the load a lot more evenly, and that's why we do that. So then you can see the voltage comes out, goes through a giant fuse, and then boom, we'll have wires coming out. Down here on the bottom, that's just our input going in, and this other thing down here in the corner, this is kind of the opposite of a boost converter. Well, sort of. This thing actually does both. It'll raise voltage or lower voltage. But essentially this little thing, I can buy this, and it just outputs 12 volts all the time, and it doesn't. So you could give, the battery could be at 8 volts or 20 volts, and this thing will still output 12. And what this does is it runs 3 cooling fans that are going to blow air. Basically all these components are going to sit in a box. So this guarantees that these fans run at the normal speed of 12 volts all the time. Because I've done some testing in the past when you run these are like, they look like computer fans. I guess they're that type of fan. And I've noticed that when you run these at high voltage, they die very quickly. So I didn't want that to happen. So that's what this is going to do. Now this diagram is not totally complete. Notably, one thing that's missing is surge protection. I want to do something on the input here to kind of capture any like high voltage spikes from, say, it's called load dump scenarios. I'm going to put something like that in here because these are some cheap supplies, and I haven't really looked over them, but I seriously doubt they have much in the way of protection for load dumps and high voltage spikes, things like that. So we're going to put something in here to protect for that. I just got to figure out what we're going to do and buy that stuff too. And we'll probably do it for this guy, same thing. I just don't want to risk that breaking. Not sure what else is missing on this box, but essentially this is what we're doing. So all the stuff you see here, we actually already ordered just about everything. We're going to build our own enclosure, and I haven't bought the material for that yet. But all the components you see in this box, short of like bolts and wire, but all the main stuff, the fans, these parts, that big fuse, all of that's ordered. And it'll all be here in a few days. So this is just like another project we spun up. So essentially the way we got to this point, this is one of those things I've always wanted to do, and what I'm running into is I got to do the electrical on the car, and it's like, you know what, you just got to do it all at once. Electrical is one of the worst things to have to go back and mess with later. You kind of want to do that once and be done and never touch it again. Getting into wiring harnesses, like even if you just need to tap into something, like after you've already buttoned it all up, you got to go like cutting zip ties, peeling back, insulation, and depending on how you do your wiring, like if you have sleeves over it, you might have to cut heat shrink. You may have to cut sleeves. Some of that stuff's not really designed to be serviced. So, and I don't want to do that. I'd rather do this once and be done. So I was like, all right, what's going in the system? And then this is one of the things I've always wanted to do. So I was kind of like, I'm thinking about how hard it would be to build all this. And I was like, wait, how much stuff could I buy? This is something I kind of learned at work is, hey, buy stuff that'll do what, if you need to build a complex system, don't invent everything. Just go buy everything, or as much as you can, and do the hard parts. Do what you have to do, but don't do everything just for the sake of it. So in this case, like in this box, we're probably going to build an enclosure just because I haven't found one that I think is suitable. But everything that goes in the enclosure is a buy part. And I really just, basically you just bolt them all in and connect the wires. So this shouldn't turn into a long project. Fingers crossed, famous last words and all that, but I don't think it's going to be that bad. We are going to have to test this some because I don't want to wire it in the car and then have to take it out later because it doesn't work. So we are going to have to do some testing. And since it's going to be outputting 17 volts, I got to figure out what type of load we're going to put on this to test that. A little bit of thought's going to have to go into that. Also, I just thought about inductive kickback and loop currents. We're going to have to think about that a little bit too, make sure we're not missing something. But yeah, this is part of one of our little projects. We've got another one. I guess I'll show you guys that next time. Another project unrelated to electrical, but this one was kind of important. We've been wanting to do this for a long time. The ignition system is something on my car that's kind of been a weak link. I've always had to gap my plugs down. I think the plugs in the car now are at like 18 thou, which sounds crazy, but I had to gap them down to 18 thou so that when the car heats up and you're running 40 pounds of boost and you're not running a ton of ignition advance, that it would actually spark. I don't know, maybe this makes sense. Some of you guys probably already know this, but when it comes to spark blowout, maybe I should save that for another video. I don't know, I'll just tell you real quick. I can go into more detail later if anybody cares, but basically, if you have a misfire and you don't have enough ignition system to get it to spark reliably, one of the ways you can improve that is just run more spark advance. Now, you would never really do that for the sake of ignition coils, but when you run more spark advance, it sparks sooner during the compression stroke. And since it sparks earlier, it hasn't compressed the air-fuel mixture as much, so the pressure is lower, which makes it easier to ignite. So basically, if you have a really aggressive spark map, you can get away with less of an ignition system. If you run things kind of soft and you keep your timing a little retarded, that means it's going to be later in the compression stroke before you fire the spark plug. It makes it harder to light the mixture. So that's one thing I run against. I only run, what I used to run was about 15 to 17 degrees of ignition advance, running 40 pounds. And I probably should have been running more, but that's what I ran. And what was the other thing? Oh yeah, so the other thing was the spark plug gap. So I was saying I run 18 thou, and I had to do that, but what I would like to do is to run 40 thou, 50 thou, 60 thou. Like, I'd love for it to be some crazy spark plug gap. There's several benefits that you realize by having a large spark plug gap. You can burn leaner mixtures, it starts better, it idles better, it drives smoother, it gets better gas mileage, and you can actually run slightly less spark advance. It actually improves the, I don't know which word you use, but it's the efficiency of the motor. When you can light the mixture quicker, that actually helps you. So that's pretty cool. And you know, I've tried before, like running, if you turn the boost way down and put the spark at like 40 thou or 50 thou, it's noticeably better. It spools better, a little bit better, drives better, starts better, idles better. So hopefully with this hotter ignition system, we'll see some of those gains as well. We'll be able to run more gap. We're also going to do some upgrades. I'm probably going to get new coils, and I'm going to relocate them, new spark plug wires, things like that. So we're doing several things at once, but this is something I've been wanting to do. So we're going to try this sucker out. And like I said, we'll get the ignition coil benefits, and we'll get the constant voltage on the fuel injectors. And that's going to be nice. So, you know, basically every time you start the car, your battery might drop down to like 8 or 10 volts, but I will not be concerned with that because my injectors will be getting a constant voltage all the time. So one less thing to worry about. Anyway, that's going to wrap it up for this video. You guys take it easy.